Uh, Good morning, Professor Dr. Kollam Chatterjee and dear participant for the third day session. I'm Dr. Ujjwal Vishwas, Department of Computer Science, IIT Bhagalpur, the co-coordinator of this 5-day short-term course on machine learning in healthcare and agriculture. I'd like to express my sincere gratitude to Professor Chatterjee accepting our request to deliver an expert talk. It is my pleasure to introduce the esteemed Professor Dr. Kollam Chatterjee from the Department of Electrical Engineering at the Indian Institute of Technology, ISM, Dhanbad. Professor Chatterjee is a prominent figure in both research and academia with with a wealth of experience and expertise. His research encompasses the applications of subcomputing techniques in power system operation and control, small signal stability, and renewable energy. He has already guided 15 doctoral students with 4 ongoing students working under his supervision. Professor Chatterjee is an active member of professional bodies such as IEEE, IST India, and IE India. He contributes significantly to outreach activities, delivering smart talks and participating in numerous conferences, seminars, and workshops. Additionally, he has organized 10 short-term courses and overseen 3 projects as a principal investigator. Professor Chatterjee scholarly contributions include 49 papers publication in internationally recognized ACI index journals and 17 conferences along with 2 book chapters. His current ACE index is 26 and the total citation count of his paper is 2,825 according to the Google Scholar information. Furthermore, he has held over a dozen key administrative posts, including the head of the department at IIT Dhanbad. We are honored to have Professor Chatterjee with us today and look forward to his valuable insight and expertise in the field of machine learning, AI, and its application. Thank you. Thank you, sir. I'm handing over to sir. Good morning, sir.
Okay.
One second.
Okay, good morning, everybody. My PPT is visible?
Yes, yes, sir. This is visible, sir.
Okay, thank you. Good morning, everybody. So today I just present the topic related to your short-term courses, that detection of the fatal diseases from biomedical signal using the hybrid deep neural network models. Now, what is the background behind it? Means what is the requirement of the why we actually apply the neural networks or any deep learning methods in our biomedical signals? You understood this thing when we actually go through the any computerized and automatic detection and diagnosis of the fatal disease with the accuracy are very important for the medical expert and doctors for the right treatment. Even today, most of the physical and the visual examination is done manually to detect any fatal diseases, where the chances of the human error, medical error, and the diagnostic error are more. Also, the conducting such physical and visual examinations are quite costly, which could not afford by many low-income people. It is therefore necessary to use non-invasive technique for automatic and computerized detection of abnormality from the human body, which there is a lower probability of the errors than the manual procedure. by acquiring and analyzing the electrical signals from the human body which represent the functionality of human organs. For example, the ECG represent the functionality of the heart. And so in this presentation, and we actually discuss about the how the automatic and computational detection of the fatal diseases with the ECG signal in the focus. Now the total presentation organization, we actually go through the what is the literature review of the when the abnormal ECG signal is occur in our system, how actually we detect the cardiac arrhythmia using the novel future extension techniques. Now, mainly the disease of the abnormality human body can be detected by the use of the variety of the methods, that the physical and visual examination, which may be human intervention are involved. The the cardiovascular disease are the one of the most deadliest diseases in the world. The mortality rate of the CVD is higher in the world. In the analysis and detection of the CVD on electrocardiogram signals are required. The selection of the ECG signal have been selected based on the database availability, morality, and non-invasive technique and the previous research. So the when you actually go through the literature review of the biomedical signal processing, the two methods is actually the available. The traditionally machine learning approach or deep learning approach for the ECG signal analysis. If we go through the literature survey of the machine learning methods, the mainly this is actually the considered the independent component analysis, discrete wavelet transform. And these techniques is actually use the support vector machine neural network and the different of the probability neural network techniques. Mainly the database used for the ECG, when you can find out the ECG data, we use the standard MIT DB data set is actually we use. So the different type of the techniques is available from the system, and we got the accuracy from the machine learning method 99.28%. But what is the disadvantage of the machine learning methods when the large database is actually available? So the machine learning approach is actually not suitable for the we analysis the whole system. So the increase the database, when the database is actually increased, we actually consider go through the deep learning neural network technique. So this is actually the different type of the methods is actually available. The computational neural networks, conventional neural networks. So we also use the same database for the when we use the deep learning neural network techniques. Now, mainly this presentation we actually consider the biomedical signal processing. That is the we go through the ECG signals. Now, before we go through the ECG signals, so we actually go through the total what is actually total structure we today I discuss here. So first the database collection, how we actually go through the pre-processing and denoising the signals, smoothing the signals, peak detection of the ECG signals, proposed future extension algorithm, optimized detection, and the what is actually can got the results, and then we can go to the conclusion. Now, what is actually the how actually got the ECG signals? So the electrical activities of the different human organs are represented by the bioelectrical signals, while the ECG is the one of the bioelectrical signals originate from the heart. The instrument which is used to observe the working of the heart is called the electrocardiogram. It is very important to know that electrocardiogram is an instrument which used to display the electrical signal generated due to the functioning of the heart. To recognize the arrhythmias or abnormality of the working of the heart, the ECG signals are being printed on the graph paper and diagnosed manually by the doctors and the expert. So you can see that the when we actually go the different type of the wave, or you can also say the wavelet or wave function is actually generated by the and the ECG function means that depending of the heart functioning. So we actually got the type of the waveform. So now what is actually the representation of the this waveform? What is actually significance of the this P wave, QRS wave, T wave, and what is actually depending of the this is actually the ECG signals is actually contain both the waveform as well as the your wave segment. So the electrocardiogram signals represent the recording of the ECG is done by capturing and amplifying the small very small variation in the potential difference which form the electrical impulse on the surface of the human skin due to the cardiac functioning. The blood pumping phenomena by the heart either into the ventricles in the entire body of the artery and ventricles respectively known as the contacts and the depolarization, and returning to the original state or the resting state or the relaxation state is called the relaxation and the depolarization. Mean the two state is there. One is actually the deoxygenate, the blood is actually coming to the your heart, and after oxygenate again the blood will be pumped to the whole the body. So there is the two parties there. One is the depolarization, another we actually consider the repolarization. The cardiac and the heart function is the combination of the contraction and the relaxation, or depolarization and repolarization in the synchronous manner. The contraction and the relaxation are the mechanical phenomena, whereas the depolarization and repolarization are the electrical phenomena. The sequence of the depolarization and repolarization is the synchronized way is identified as the potential difference which causing the electrical impulse, which are the recorded in the form of the waveform by placing the electrodes in the skin of the body parts. The recorded ECG waveform consists of the short waves such as P, Q, R, S, T, sometimes U, followed by its segments, and all type of the waves in the ECG signal is segments generated by the depolarization and the repolarization process. So this is the what is actually significance of the different wave. Actually, when we actually go through the our ECG wave, we actually got the P wave, QRS wave, T wave. So here I actually discuss the what is actually duration of the different of the wave and what is the significance of the wave. So P wave is actually occur due to the contraction of the artery used for analysis the artery arterial rate, and this duration is only the 60 to 80 millisecond. And when the QRS complex, you can see that this QRS complex wave is there. So this is actually occurred due to the depolarization and ventricular content, the most significant information of the ECG signals. This signals is duration is very high. This is 80 to 120 milliseconds. RR intervals, that is the interval of the conjugate R peak, two conjugate R peaks used to measuring the rates, that is the our heart rate valve. So that is the 0.6 to 1.2 second, mean that the conjugative to R, what is actually the total time duration, that is the points. These all the duration actually give the normal heart rate. We not consider abnormal. This is actually the your specific value we actually discuss. PR interval, also known as the PQ interval, duration between the onset of the P wave to the onset of the QRS complex. That is actually given this is the PR interval. This is actually already mentioned here. PR interval means the generate the P wave up to the R intervals, mean the what is the peak. So this interval times we actually represent by the 120 to 200 milliseconds. PR segments, also called the PR segment, is the end point of the P wave and the onset of the QR complex to 50 to 102 milliseconds. Similar, the interval between the terminator on the QR complex to the beginning of the T wave. So this point we actually consider the Z point. Mean the end point of the your PQ wave and the starting point of the T wave. The starting point of the T wave. So this is actually we consider the Z point. And the ST segment is actually the interval between the Z points to the onset T wave. That is value is actually given to the 100 to 100 to 20 milliseconds. So this is actually the all the normal heart rate scenario. What is actually significance of the P wave, QRS wave, T wave, and QRS wave. So the mainly you can see that the from this wave form the QRS wave. If we actually pick the QRS wave form, so we actually find out that what is the different segment. Later we actually discuss about the normal or the abnormal heart rate conditions. So this is the amplitude. Previous cases we will not go through the amplitude wise. We can only find out the what is the description and the duration of the different wave. Here we actually go through the what is the different amplitude wave. So P wave, the amplitude is very small, 0.1 to 0.2 millivolt, and duration is already this 60 to 80 millisecond. And the T wave, this is the 0.1 to 0.3, 120, 160. Only the QRS complex, the amplitude is very high. That is the 1 and 80 to 120 millisecond. Now, if any abnormality, if the normal rhythm of the heart, where there is the no disease or disorder in the morphology of the ECG signal, is called the normal sinus rhythm, NSR. And you know that the heart rate actually is 72, but the range is the heart rate of the NSR general characteristics by the 60 to 100 beats per minutes. So the normal, when we consider the normal heart rate, normal heart rate condition, so we actually got that this is the different amplitude and this is the duration. But if any abnormality is actually coming in your system, if any blockage or anything is actually coming, so we actually not got the proper ECG signal. So normal healthy person ECG comes up in nearly the periodic signals with the depolarization followed by the repolarization at equal interval. However, sometimes these rhythms become irregular. So the cardiac arrhythmia is a term for any of large heterogeneous group of condition in which there is abnormal electrical activity in the heart. The heartbeat may be too fast, too low, and may be regular or irregular. Arrhythmias come to the in the different other varieties. So if the normal condition is actually coming, we actually got this type of the signals. But if the abnormality is actually coming in your system, if the abnormal heart rate is occurring in your system, so we actually finding out how actually got the abnormal heart rate and how actually predict the what is the fatal disease. So that you understand this thing in the when you can consider in the doctor's term or medical terms, this is the abnormal heart rate or the any this type of the condition is considered myocardial infarction, is the medical term used to describe the heart attacks that include the death of destruction of the heart tissue as a result of a shortage of oxygen and the nutrition. The myocardial infection is sometimes referred to as a heart attack because it involves the death or damage of the heart tissue caused by the lack of the blood sulfur. The coronary heart diseases is the most prevalent and lethal severity in which the blood flow of the heart muscle is restricted owing to the partial and the full blockage of the coronary arteries. The coronary arteries are responsibility for supply the oxygenated blood of the cardiac muscle. If there is any blockage in the coronary arteries, the heart muscle segment may die as a result of the lack of the blood flow. Many signs that can may be observed in the case of MI include the chest discomfort, breathing difficulties, and unconscious. But the ECG, you can see that when the ECG, when you go to the ECG, so this type of the waveform is instead of we actually got the periodic waveform, we got the this type of the abnormal signals to the system. So this is actually the graphical view is the premature ventricular contraction. This is PVC or MI bits of the ECG shown in the figure. So you can understand this thing when we any abnormality is coming in your in the heart. So that time we have not go to got the periodic waveform, periodic ECG waveform. We got the abnormal waveform in the system. So this this system we actually divided into the different types of the abnormality. So sometimes this is actually considered the bundle Blanch box. If the passage of the heart conduction system, if there is any blockage or interruption or delay during the electrical impulse to produce a heartbeat, it is called the bundle Blanch box. Mainly the bundle Blanch box are divided into two classes: left bundle Blanch box, that is the LBB, and the right bundle Blanch box, that is the RBB. Left bundle Blanch box is the abnormality in the electrical conduction of the left branch of the cardiovascular system, and the right bundle branch block is the heart condition in which the right branch of the human heart is affected due to the some abnormality. Also, the premature ventricular contraction is the PVC, is the normal heart rate onset of the ventricular occurs prematurely. It means that it occurs earlier than the normal heartbeat, called premature ventricular contraction. So this is the different condition is occur if the abnormalities occur into the heart. So how actually we can generate the ECG database, or how actually you can predict the abnormality into the from the ECG signals. how actually got the abnormality means the when you actually predict the system, what is the how actually you can generate the database, and from that database how actually you can predict the which type of the abnormalities occur in the system, how actually predict it. So the first thing is actually you can generate the ECG database. So mainly we when we ECG database, every researcher actually we use the MIT BIH Arthmetic database directory of the ECG signals. This database contains 48 records, each records in the 30 minutes long. 48 means the different patient. This data will be actually they will be given. So this record of the data is 30 minutes long. The number of record used for experimenting of the future extraction algorithm is 26. 48 data up to this we only use for the 26 data for the future extraction algorithm. Total 8500 ECG bits has been utilized for the validation of the system accuracy. 80% of the total data set, that is the 6800 ECG bits, have been used for the training, and remaining 1700 ECG bits are used for the test for proposed classified. Now, how actually you can this database, how actually you can process and how actually use in our prediction purpose? You understood this thing. First, what is the different step? How actually you can got the different type of the database we actually use? So first cases is actually the raw or when a noisy database we actually got the system. First thing is actually you can denoising the databases. After that, we from the filtering the circuit, we actually got the exact database in the system. So first database is actually noisy database. From this noisy database, we actually the pre-processing stages is there. So people processing stages we actually consider step by step. I discuss about this thing. First, we actually consider denoising using the we use the wavelet transform. That is we actually use the MRWT waveform. Then we actually go from the this is actually you can consider the multi-resolution discrete wavelet transform. And removal of the baseline depth, we actually consider the filtration of the system. So after we can got the exact database, then we go to the ECG peak detection. ECG peak detection, we already go to the here the QRS complex is actually the most QRS is actually the most peak in the ECG database system. So we mainly consider the how actually can peak the our peak wave when the R peak. After that we actually peak the R peak. Then this is actually you can put into the our neural network, that is the multi-probability neural network, and from that we actually predict the different type of the what is the abnormality in the our from the database. So this is actually the proposed methodology, means the what is the different step. First, the raw noisy database pre-processing test, that is the pre-processing data stage. Then from the we actually consider the RP detection of the ECG signals. Next step, then we actually process of the future extraction technique, that is we can pick the RP, and after that we actually consider the multi-layer probability neural network classifier. So first stage is actually the signal processing. So the better extract feature of the system processing, pre-processing means actually first we actually consider what is actually data we actually got from the MIT database, that is actually the noisy database. So the any database when you actually any networks when you can predict. So first stage is actually the processing the data. So first stage is actually the signal processing the data. So signal processing is the first stage is the how actually can processing the data. So better extract the feature of the increase the system efficiency. It consists of the denoising the ECG signal and baseline warner removal for the work. The denoising of the ECG signal, reducing the unwanted information, and denoised signals are most suitable to increase the system performance by providing the appropriate content which is required for the signal classification. So how actually you can denoising the procedure, denoising the signals. Here we actually use the we wavelet transform. Okay, so there is the three different step is there. First we decomposing, thresholding, and the reconstructed. So why we actually consider the four because the in the ECG signal is the non-linear as is non-stationary. The nature of the curve is actually same as the wavelet departure function of the wavelet fourth order system. So that point of the view here that we actually consider the fourth order differential function with the 5 level of the decomposition. So 5 level decomposition when we use, so there is the 5 step is there, D1 to D5 was collected and soft thresholding. I just later we actually give the physically value. So how actually decomposing the, this is the actually we use the decomposing level was collected and soft thresholding in the applied to the each level. The deionization ECG data has been done using the multi-resolution discrete wavelet transform. The threshold value has been carefully chosen for different type of the noise of the ECG signal and with automatic thresholding applied to the initial level of the noise reduction. The fifth level of the wavelet decomposition, namely D1 to D5 are selected and soft thresholding is applied to the each level of the decomposition from D1 to D5. The deionization ECG signal has been reconstructed by combining the fifth level details D5 approximately A5 coefficient from the last stage. So the first stage from the denoising the our signals, we actually use the discrete wavelet transform. So here the four order representative function with the 5 level of decomposition we use. First we decomposition, then we thresholding, then we reconstruct the signals. The baseline wonder removal mainly used for the filtering the system. So what is actually the noise is available, or again the span of the moving average, consider the 150 of the smoothing it, and finally subtract for the smooth signal for the original signal. Hence this is computed signal is the free from the baseline depth which is shown in the figure. So you can see that first signal is actually the original signal is this is the noisy ECG signals. So after the denoise the ECG signals using the wavelet transform, we got the, this is the second cases. You can see that this is the, we actually got the filter, means the denoisation the filter ECG signals. So this is actually the after we denoise the ECG signals through the wavelet transform. So after the wavelet transform, the next stage is actually you can go through the baseline wonder remove ECG signal. So here you can see that the we actually what is the here the in the baseline what is the different of the noise is available, that is actually smooth after we use the baseline wonder remove ECG signal. So this filter we use got the numbers. So first step is actually our means the noisy signals we actually denoise ECG signals, then the filtering the signals and got the actual signals after removing the noise. Then the next step is that the detection of the R peak. So the detection of the R peak after the pre-processing step that include the denoisation, smoothing, and the removing the baseline wonder of the ECG wave, it can be further processed to extract the useful information. So the why you actually go through the R peak again? I repeat, because we always say that the R peak is the magnetism amplitude of the R peak is equal to 1. So we actually see that the when what is the maximum if we extract the R peak. So if any destroyer is there, so that is actually first effect in our maximum R peak in a system. So the ECG signal morphology includes the 5 main peaks from P peaks to T peaks, where the QRS peak is called the QRS complex, which contain the maximum information of the cardiac functions. So you understood this thing. That point of the view, our main aim is that we actually detection of the R peak in our system. R peak is the highest peak of the ECG waveform, and it is generally in the center, and also the energy of the QRS complex is surrounding around this peak. So the first and foremost requirement is to detect the R peak based on which the QRS complex will be extracted. In this work, we actually use the multi-resolution discrete wavelet transform with the 6th order, that is the wavelet has been used for the R peak detection. So what is the next, how actually we can go through the extraction techniques? Before we start, you can see, just we go through this expression, you can see that where we actually consider the 8th order system. Out of this, the mainly function D3, D4 and D5 we use for the calculation of the feature extraction techniques. So the denies and smoothing the ECG signal is considered, and decomposition signal using the multi-resolution discrete wavelet transform up to the 8th level, and wavelet transform used to the decomposition in the 6th order system. So 3rd, 4th and 5th level of details coefficient are selected for extraction of the QR section. Since D3 and D4 and D5 consider maximum information of the energy spectrum, here D3, D4 and D5 are the details coefficient of the wavelet. So you understand this thing. What is actually we got after denoise the signal, that signal again we actually go through we decompose the signal up to the 8th level wavelet transform. And when we decompose in the wavelet functions, up to the 3, 4th and 5th level is we use, because this is actually selected extraction the mainly the QR section, because this is actually considered the maximum information and the energy spectrum. Here the D3, D4 and D5 are the details coefficient of the wavelet. So what is actually can compute the total energy? We find out the X is D3, D4 and the D5. Mean the addition of this. After that, we actually got the new function. You can see that we got the new function. We generate the new function y. Y is actually the D3 into D4 plus D5 up to 2n, when n represents the level of decomposition. Then we actually determine the value of the Z. Z here actually represent what is the maximum optimization value, means that we find out what is the maximum peak. So Z is actually given what is the maximum using the optimization technique. Ensure that the value of the Z is maximum, means we actually find out what is the maximum peak in the overall this wavelet. If the value of the Z is maximum, then the maximum amplitude is recognized as the R peak. If not, then Z is optimized and then the maximum value is determinant. This technique is adaptive because it automatically detects the maximum amplitude for any real-time stored ECG signals. Now the maximum amplitude point is labeled is R. Z maximum is R, means we actually go through the number of points. We total 100 points we actually generate from the Z, this axis. Out of that, we actually find out the 21 points. You can see that how actually got it. Now in the maximum amplitude point is level is the Z maximum is the R, and it is initially at the R equal to 0. Then determine Z1, that is the R is actually initially is the point. Then from that particular point, we actually go to the R is equal to minus 50, R is equal to plus 50. That is means total 100 points we actually find out what is the minimum and what is the maximum duration of the Z. Means what is the, and starting from the R to Z1, R to ZH, determined using the Z1 up to 5 to 8, means the every 5 interval up to Z1 to ZH, we actually find out what is the maximum peak in the system. So this point between the Z1 to ZH give the 21 feature points. Name is P1 to P21. 21 point is selected such a way that it include the QRS wave in the ECG signals. So we actually go through the that is actually the algorithm. But when we actually go through the your graphical representation, then you better understood this thing. First thing is you can understood this thing. What is actually denoisation signals that we actually decompose into these 8 levels. So the small scale represents the high frequency component and large scale represents the low frequency component in the signals. These signals is actually represent the level 3 level flow, level 3, 4, 5. Level 3, 4, 5 show the better with the QR complex, while all other apparently noisy with respect to the QR regions. You can see that the D5, D6, D7 is the noisy, is only D3 and D4 that noise is actually come. So that point we actually use the D3, D4 and D5 where the maximum information is available the QR signals. So this is actually the amplitude. You can see that this part is actually the two parties there. There is signal and approximation. Here the coefficient signals and the details of the signals is that. So this is the actually the decomposition ECG signals up to the 8 level DV6 wavelet transform. So first the deep what is the wave deionization signals is actually coming, that we actually decomposition by this wavelet transform. So this is the three signals we actually got, D3, D4 and D5, what we actually discussed in the algorithm. So you can see that first cases up to first we actually denoise and smoothing the ECG signal, then the decomposition of the 8 level using the D6 wavelet. So this is the actually the D1 to D8 wavelet transform. That is actually the decomposition up to the 8 level using the DP6 wavelet transform. So this is the our 8 level, that is actually D1 to D8 wavelet transform. Within this wavelet, we actually consider the these four information D3, D4, and the D5. D3, D4, and the D5. Out of this wavelet, we actually find out the what is actually the your wavelet transform waveform. This waveform we actually plot E1 and the E2. You can see that this phi 1 E1 and the E2. This is actually maximum peak we actually consider from the yes sir. Then from that we actually detect the R peak. The rate signals is actually a number of samples. We identify R peak of the ECG waveform. So you can see the step by step. First we actually the power spectrum. After that we actually find the X and Y, D3, D4, D5. Define the function Y is equal to D3, D4, D5. We find out the Z. Z is actually we give the maximum amplitude. If the amplitude Z is maximum, the optimal Z find the maximum amplitude. If yes, maximum point of the each is the ECG record, then initially the R equal to 0. The Z maximum R is determined. We actually consider we got the 100 points or 100 samples. Within the 100 samples, we actually got the 21 features in a system and 21 point feature of the ECG signal. So this is actually the feature extension algorithm. So you can see that the first cases we go through the we detect the R peak, and from this R peak we actually got the this type of the 21 feature from the your denoisation signal. So this is actually generate the our peak QRS signals, and this is actually we got the maximum peak from that particular signal. So this is extra the QRS complex or normal bit in the 21 features points. So within the 100 sample point, we actually got the 21 features point, and from that 21 features point, we actually got the what is the RP system. So in this way, we actually extract the features from the ECG signal. So after we can actually got the features, so we see that the what is the different of the normal abnormality, what is the different of the features we actually got from the these signals. If the normal signal is actually coming, so you can see that this type of the features is actually coming from the systems. If the normal signal is coming, if there is the any left bundle block, is the left block left side any block is actually coming, we actually got this type of the signal from the our database. So if is we actually consider right side, if there is any block, so that is actually got the RBB, this type of the signals we actually got. This is the PVC and this is the pace bit. So you understand that this is this type of the 5 different type of the features we actually got from the our organization. So again I repeat, first we actually consider the D9 what is actually the our database. From database, our first step is that we actually the denoise the database in a system. So first step is actually denoising the database. After the denoise the database, we denoise the database. We actually use the DWT, that is discrete wavelet transform. The fourth order function we actually use mainly for the denoising the signals. Then after denoising the signals, we actually consider the baseline wander removal. The baseline wander removal is nothing about, this is actually the one type of the filter circuit, that is the filtering the your lower levels. So after the you denoising and the baseline or filter, so we actually got the remove ECG signals from these denoising noising the after denoising the noise we actually eliminated. So our next point is actually the detection of the art peak. So the detection of the art peaks, we actually use the multi-resolution discrete wavelet transform with the 6th order dB function, dB6 functions. When we actually consider the art peak feature extension techniques, we actually got these 5 different type of the abnormality or extract the features. First two cases you can see that this is the normal features, A cases. B cases, this is the if there is any abnormality, that is the left block type, that is the LBB types is there. C is actually considered if the right side any block is there. So we actually got this type of the wave forms. So if the PVC actually the premature valve or in the PVC contraction is there, that is premature ventricular contraction is there. So we actually got this type of the waveform, and this is the pace beat. So this is actually the if the abnormality beating is actually occurred, if the normal beat is not occurred, so we actually got this type of the waveform. So this is the 5 different type of the one is A is normal condition, B, C, D, and E is actually considered the abnormal database from your system. So from that database, we actually find out the how your feature extension techniques is actually the what is actually the your accuracy statistics results. So we actually go to the confusion matrix. So what is the confusion matrix? The classification purpose, the detection of the abnormal ECG beats is the binary classification problem, and that is actually represented by the 4. You can see that this we actually go to the statistics data. So here we actually consider that the 4 different data set is there. False positive bit means that if the ECG beat, actual case is if the ECG beat is normal, but your class is detected as a abnormal, that is actually you can represent the false positive beat. Second is actually your true positive beat. So if the abnormal ECG beats detected as a abnormal, so means the abnormal cases if the detect is abnormal, so this is actually you can represent the TRP. 4 different classification we consider. FNB is actually the false negative beat, that is abnormal ECG beats detect as a normal, and that this is actually the true negative beat. So this is actually the ECG beats of normal class classified as a normal. So the 4 different classification we actually go through the system classification. So in our case, after the classification, we actually see that what we actually classified, that is actually what is the results, what is the accuracy, what is the statistical result. From these statistical results, so we actually require this is the confusion matrix. We generate from this confusion matrix, we actually go to this part. We actually find out what is the accuracy, classification of the error, classification of the error rate, and also the specific and the sensitivity of the system. So we actually find out the accuracy, classification of error rate, specific and sensitivity, positive predictivity, F-score, and overall accuracy. So these value is actually given to you. So what is your prediction? What is your feature extraction technique? That is actually the work is properly or not. If the overall accuracy is actually represent, you can see that this is the true positive value plus 2 negative value divided by 2 positive value, 2 negative value, false positive value, and false negative value. So this is actually given the overall, mean how many value is actually given into the 2 value. What is this? That is actually given your overall accuracy in the system. Sensitivity is actually given the 2 positive value divided by the 2 positive value plus false negative value. So this value is actually represent the significance of this value is actually how closely you can actually predict your system. Predict means actually your future extension techniques. What is actually you can extract features technique, what is you can adapt, that is actually your work is properly or not. So this is the statistical data is actually given to the in your after the you predict the system, this value is actually determined. So your future extension technique is actually good or bad. So if this technique is your accuracy is very low, so again you actually go through the future extension techniques. So your first step before we actually go to the your network and train the network. So first case is required to the generate the exact data in your system. So after that you can extract that. So that data we actually put into the our traditional neural network system. So everybody most probably know the neural network. I not go to the system. You know that there is the three different layer is there: input layer, hidden layer, and the output layer. Between the input and the you can know that your input mainly your neural network is actually required the weight matrix. At no, depending on the activation function is when we upgraded we actually upgraded your weight matrix and the activation weight matrix and the bias of the in the system, and we actually got the result. So in these cases we actually use the probability based neural network structures, probability based neural networks. So a multi-layer probabilistic neural network we actually use. The multi-layer probabilistic network classifies the fast processing time with the good accuracy, and the FPN is the type of the feed-forward neural classifier having the 4 layers: input pattern, summation, and the output. It is also called the multi-layer feed-forward neural network. The probability of the each new class is estimated by determining the PDF of each classes, and the final classes is allocated depending upon the maximum probability using the rule. Now, what is the multi-layer probability? How actually can use in this particular cases? We already say that we actually give the 21 feature we extract from the your signals. So that 21 features we actually give the here the input. Okay, this is actually the we can go to the input, and there is the 2 layer is there. So we actually go to the pattern layer, and the one is actually go to the summation layer, and this then we actually go to the output layer in a system. So the input layer, what is actually the input? That is actually you can generate from the system. Then we actually go to the hidden layers, and the 2 hidden layers we actually use in this particular cases. And how many layers we actually consider, we are not go to the details about this system, but this is the architecture of the multi-layer probabilistic neural network. So basic architecture we use for this particular cases. So how many data set we actually use? So out of the total system, each system we actually consider 8500 ECG bits. Out of this 8500 ECG bits, out of these ECG 176800 we use for our training purpose, and 1700 bits are used for the testing to detection process. MITB database used to assessment classification performance. We have been chosen the 500 bits as a normal ECG, 300 bits. This is actually the what is the 5 classification. What is actually you can do? What is the different bits we actually use? We actually 500 bits is the normal ECG bits, 300 bits from the PVC, 300 bits we use LBB, 300 bits of the paste ECG, and 300 bits for the RBB. So you can understand this thing. 5 different classified we actually use. From that we when we actually training the data, we actually use the 500 bits for the normal ECG bits, 300 bits for the PVC purpose, 300 bits for the LVB, that is our left bundle block, 300 bits from the pace ECG, and 300 bits we actually consider the right block bit. So you understand this thing. This 500 this database we actually use mainly for the training purposes. And use of the FPN classifier to classify the results of the results is compared with the 3 other neural classifier, that is backwards neural network, multi-layer perceptrons, and the support vector machines. All the MPN provide the better result compared to the other classifier using the 21 future point as a input. So you understand this thing. When we classified the other base, you can see that when you can consider the currently classified 500 database, you can see that when a currently when a backwards algorithm, the normal out of the 500, the 494 database they will be use the properly classified. 1, 2. This is actually different classification model. Out of 300, 294, you can consider 292 data. They will be actually selected. 293 is properly this out of the 500, 291. So you can understand this thing when you can add 2 positive. That is we actually consider that this is the four different confusion matrix. We actually throw this thing actually 2 positive, 2 negative, and this way. Okay, this is the 495 67 and 171, 295 57, 292 87. This is actually total data we actually consider 2 negative. So that this is actually the accuracy level. After that, when you can consider backwards algorithm, so this is actually given the 97.94%, and this is the percentage PRAC. This is actually the overall accuracy. Okay, this is actually the what is the we can go to the confusion matrix. That rate we actually find out here: the 2 positive, false negative, 2 positive. Then you can see the percentage square sensitivity, positive, predictive, classification error rate, overall accuracy. So that is actually you can that data we actually represent here. Overall score actually scored in a system, and the overall accuracy in the system. So this is actually given the 97.94. When you can consider the multi-layer perceptrons, so this is actually given the average value. This is the 98.53% data, and when we actually consider support vector machine, that is actually given the 99%. And when you can consider the multi this is the MPNN, that is actually given the 99.53 system. So you can see that these cases actually give the more accuracy than the other methods. But you understood this thing how we actually go through the results. I mean, how actually can step by step how actually we find out. First, we actually we got the data set. From that data set, we actually deionization the data. We use the for deionized data set. We actually go through the wavelet transform. We actually go through the wavelet transform. After the decomposition of the wavelet transform, this is the future extension technique. So after the wavelet and transform, we actually go through the baseline detection. After that, we use the R peak detection. The feature extension algorithm, we use the deionization technique. So this is the decomposition up to the 8th level wavelet transform. We actually mainly use for the out of the decomposition. We actually use the what is the maximum jet in the system. Out of the maximum jet, we actually initialize the R equal to 0. Out of the 100 points data set, we actually find out the 21 features. From these 21 features of the ECG signals, we use as an input of the neural network. So this is the different step we actually adopt, detect the R peaks, and these 21 features from the your system, that is actually you can put the input on our classifier. So from this classified, we can actually see that the different of the abnormality is actually coming in the system. So that is actually we can predict. So these 5 state we actually predict: normal, that is the left side block, right side block, PVC, and the pace beat. Then we actually go through the statistical method. So from this confusion matrix actually give your statistical data, mean how your prediction, when you actually predict, how accuracy your prediction is there. So this is the 4th part we actually consider: the false positive bit, 2 positive bit, false negative bit, and the 2 negative bit. The false positive bit we already discussed. This is the ECG. If this is the ECG bit, your actual bit is if the normal, but if your prediction is the abnormal, so that is actually can represent the false positive bit. When the 2 positive bit is the abnormal ECG bit, but detect as abnormal, means both are the same. Your input data as your output data both are the same. That is actually can consider the 2 positive bit. But abnormal ECG bit, when you can consider the your abnormal ECG bit detect as a normal, so that is actually considered the false negative bit. And if the ECG bit is normal and class classified also normal, that is actually considered the 2 negative bit. So depending on these 4 conditions, we actually find out what is the accuracy in your prediction. So that is actually we can consider the classification assessment matrix. So this statistics is actually called the classification assessment, that is called the accuracy, classification of the error rate, specificity and sensitivity, positive predictivity, F score, and the overall accuracy in the system. So this is the percentage accuracy we actually go through the system. So you can see that the overall we actually find out what is the overall accuracy in the system. We actually different type of the classification assessment measure is there, but we actually mainly one is the sensitivity, another is the overall accuracy, mean the how the system will be properly predict your system. So in this particular cases, we actually use the multi-layer probabilistic neural network. So you can see that out of this, what is the different data set we actually use. 500 bits the normal ECG database, 300 bits of the PVC, 300 bits of the LP, mean the 5 data sets. So that is actually given the here 5 different types of 500 data set, here the 300. Out of this, when they are classified, so how they will properly classified out of the 300 data set, they will be classified the properly. This is the 495, other is actually the reaches when the normal classified, they say out of the 500, 495 other is actually reaches into the this part. So this is actually the accuracy is the not 100%. So that point of the view, the system is actually given the what is the accuracy rate. So that is actually you can represent into the here 2 positive, false negative, false positive, 2 negative. So overall the accuracy is the 97.94%. When you can consider the MLFP, that is the 98.53. That is the support vector, that is the 99, and the MPNN, that is the 99.53. So if we go to the summarize, so 1700 ECG bits were tested and classified into the 5 classes. You can see that the total we actually tested into the 1755 initially 500 total bit, but 170 bit is the testing. This is actually can give the testing bits. Okay. Here the 175, what is the testing bits? I cannot go through the after the our system is trained. Then we actually the 1700 bits out of the 1700 bit, this is the 500 plus 8. You can see that this is the 1700 bits we actually considered. So 1700 bits were tested and classified into the 5 classes. 5 type of the different what is the abnormality of the ECG signal, that is actually defect PVC, RBB, phase, LPB normal bits have been detected. 21 feature points are the input, and the total 170 bits are the 5 different class are tested using the neural network. We can use the MPPNN. The overall accuracy percentage actually be excellent, which is 99.53%. And this is actually the accuracy percent of BPN, NPN is respectively 97.9, 98.53, 99%, and 99.53 respectively. Now, one disadvantage of this technique is there, limitation is that this type of technique is there. What is the limitation? Very small data set here is actually used. 18500 feature set are considered for testing the classified. Mean the 170 we actually testing for training the purpose. We use the only 1500 feature set. Traditional machine learning classified has been utilized for the abnormality detection, which may not perform well in the large database. The system accuracy mainly depends on the feature extraction techniques methods. I always that is the main thing is actually how actually the feature extraction methods mean the how actually you can consider the RP. If your feature extraction method is not properly, your accuracy is not the good. Okay. And the large database can be considered for the training the model be achieved by combining the multiple data set will be used. If the here only you can we consider only the 5 different data set, means the 5 different abnormalities. If the large number of abnormalities occur, so at that time your system we actually predict the large. This system is not properly predict the system. So the data misbalancing problem is also they considered. Anything, any question is there from up to this? Hello?
Here, anyone have any question to respected sir?
Good afternoon, sir. Sir, the online data sets available for images or any equivalent distance value are supported.
This is the data, not the images is actually given. They will be given the data set. Okay, they will be given the data set, and you can actually draw that data set from your system, not image data set. They will be given the original data set in the files. Okay, CVV Excel file is the CVV point of the view.
Okay, thank you, sir.
Anybody, any question?
Is there anyone have any question to say? Participant, if you have questions to share, please ask now. Will no one asking any questions? Then please continue on where it stopped.
Okay, okay. Then I stop here. Okay, if anybody no question.
So student or participants are not asking any questions, so I feel sir have done, and I want to congratulate him and I thank you very much for his informative presentations. Thank you, respected Professor Dr. K. Chatterjee from the Department of Electrical Engineering at the Indian Institute of Technology, ISM Dhanbad. One enlightening expert talk on healthcare systems modeling. Your valuable and comprehensive presentations showcase the diverse applications of ML in predicting diseases or abnormalities uh, to show how in human bodies diseases in disease identification using the electrocardiogram biomedical signal processing. Additionally, you provided insight into the role of machine learning in analyzing biomedical signal processing data for particularly multi-layer probabilistic neural network (NPNN) models for showing the performance in details and their results, how we should evaluate a predictive models in the area of healthcare systems. A significant focus of your talk was on the practical application in human disease prediction to enhance model performance. So I would like to thank you, respected Professor Dr. K. Chatterjee, once again for his informative and very good presentation. Thank you, sir.
Thank you. Okay.
Thank you, sir. Thanks a lot, sir. So, dear participants and students, we'll continue our session as per the scheduled times at 5:30, be at least logging to your system before 10 minutes. Thank you to all. We are closing our dispatch session morning, particularly one day's short-term course. So thank you to all once again for enjoying these sessions. Thank you.